Standard SP7 is focused on probability models. We're going to start with problem number 1. In a bag of 25 marbles, there are 6 red, 7 blue, 9 green, and 3 yellow marbles. The results of a marble being randomly selected and replaced 50 times are shown in the table. For which color is the experimental probability closest to the theoretical probability of being selected? Well, let's figure out what the theoretical probability would be for each of these. So I'm going to start with the 6 red and say, okay, for these red marbles, 6 out of 25, because this was 25 marbles here in the sample, are red. And so what would be the likelihood of choosing red out of 50? And I could actually quickly say that 25 doubles to get 50, so 6 doubles to get 12. So I would expect it to be 12. But let me just go through and work this out and say, okay, that's 25x equal 300. Divide both sides by 25 to get x by itself, which is 12. Okay, now let's look at the 7 blue. For blue, we have 7 out of 25, which is x out of 50. We get 25x equal 350. Divide both sides by 25. And x is 14. Now looking at green. For green, we have 9 out of 25. So x out of 50, we would get 25x equal 450 when we cross multiply here. Divide both sides by 25, and we get that x is 18. And then last, yellow. We have 3 out of 25 are yellow. And so x out of 50, when we cross multiply, we get 25x equal 150. We get those cross products. And divide both sides by 25, and we get that x is 6. So, which color is the experimental probability closest to the theoretical? Well, the experimental to the theoretical is 3 away for red. 15 minus 14 is 1 away for blue. 22 minus 18 is 4 difference for green. And 6 minus 4 is a difference of 2 for yellow. So the closest one was blue. Answer choice C. Number 4. The spinner shown has 8 equal-sized sections. In an experiment, the pointer lands on an odd number 55 out of 125 spins. Select all the true statements. The pointer lands on an odd number more often than expected. Well, 55 divided by 125, or 55 out of 125, would be 0.44 or 44% of the time. You would expect it to be half the time, so that's not true. The next one says the pointer lands on an odd number less often than expected. We just confirmed that to be the case. The next says the theoretical probability of landing on an even number is 44%. It would be 50% because half of them are even, so that's not true. D says the experimental probability of landing on an odd number is 44%. Well, we just found that a little bit ago. We got that number here. The last one says it's equally likely that the pointer will land on an even or odd number. That is true because half of them are even and half are odd. That's the theoretical probability. Standard SP8 is about compound events. We're going to look at number 4. Terrence is randomly selecting an outfit to celebrate Probability Day at his school. He can choose a t-shirt, button-up shirt, or sweater, denim or khaki pants, boots or flip-flops. What's the probability that Terrence will select an outfit that includes flip-flops and a sweater? So the probability of flip-flops times the probability of a sweater. Well, half of the shoe options are flip-flops. A third of the shirt options are a sweater. So there's a 1 out of 6 chance. Or we would round that to about 17% if we looked at a percentage. Number 6, to play a game, a number cube with sides numbered 1 through 4 is rolled and a fair coin is flipped. Use a probability tree to represent the sample space. What is the probability of flipping a head and rolling either a 3 or a 4? Write your answer as a percent. So I'm going to make a quick little probability tree in the space here. I know I have a number cube with sides numbered 1 through 4. So 1, 2, 3, 4. And then a coin that's flipped that could be heads or tails. So heads or tails for every one of these sides of the number cube. What is the probability of flipping a head and rolling either a 3 or a 4? So that would be these two probabilities. 2 out of 8 total, which is 1/4. And it said write your answer as a percent. Well, that's 25%. Mary's making gift bags that each have exactly 1 toy, 1 candy, and 1 page of stickers. How many different gift bags can Mary make? Well, there's 3 toys, 3 candy, and 3 sticker options. So 3 times 3 times 3 is 27 different combinations. Part B, if all the options are equally likely, what is the probability of randomly choosing a gift bag that does not contain the pony? So that's 2 out of 3 toys, has a sucker or a gumball. So that's 2 out of the 3 candies, and has heart stickers. That's 1 out of the 3 stickers. So that would be 2/3 times 2/3 times 1/3, which is 4/27, which comes out to a decimal 0.148, which is about 15%.